don't even know what that is.
It sucks.
You haven't gotten it.
It's like a tetanus shot. Like it's like cancer.
Wait,
No, to prevent HCV.
what's HPV?
Cervical cancer.
Yeah.
The cancer of the cervix.
Yeah,
What's
that's what
cervix?
We've talked about this with your doctor, don't worry about it.
I've only gotten the T-back.
I don't know.
Good.
I mean,
I don't think this is a perfect.
it's like, it's really, I hate getting it. I have to, tomorrow's my last one day for it.
Wait, you ready to 5-1?
Yeah.
We're already in that.
Wait, sum and difference of what? Wait, no, we did 5-1 and then we got really confused.
5-2 is where you got really confused. 5-1, most everybody understood.
Okay.
Because that was just the regular identities, change sign into one over cosecant.
Alright, well,
Cosine into one is secant. The Pythagorean identity, sine squared plus cosine squared is equal to 1. So I'll write a few of them up here, because we need them.
5-2, let's go to hell.
Too much.
Already?
Time to travel to hell.
Horrible. What else did we cover besides?
I
Um,
did. I forgot what it was.
Yeah, this is just.
What's today's date?
25th. The 25th.
there. Those are the ones you commonly will forget, the negative ones. Easy way to understand it is cosine doesn't change sign. Everybody else does.
I'm sorry,
Cosine,
what?
the cosine of the negative of an angle is the same as the cosine of the positive of the angle. It's the only one that does not change the sign as the negative floats through.
What is cosine of the one?
Here?
Yeah.
It's just because of
You're here.
the way the coordinates go.
Oh, thank you.
I like the jacket.
He cut his hair.
I cut my hair.
Oh.
It went short. Yeah, basically. Okay, so we have the Pythagorean identities, we have the negative identities, and then we also, for today, are going to need the cofunction identities. Let's see if you remember what the cofunction identities are. Sine of an angle is equal to cosine of the angle with a small adjustment.
I'm sorry, wait, what? What's that big blank for?
The adjustment.
Negative?
This one comes from a right triangle. And if you do sine of this angle, cosine
It's
of
like-
that
Be
angle.
like,
It's like a.
the sine of that angle is the same, or cosine of that angle is the same as the sine of that angle.
The sine of this angle, the sine of this angle is the
Is equal
same
to
as
the
the
cosine
cosine of that angle.
That's what I said.
Oh, yeah. So what goes in here is pi over 2 minus x to get to the other angle in the right triangle. The other acute.
Can you explain that?
These two angles add up to 90.
Right.
If you're talking about this one, to find the other one, you do 90 minus whatever this one was.
Why did you get 90 minus x?
I did, 90 minus x.
Does it matter if we use pi over 2 or 90?
If we're talking about radians, pi over 2. If you're talking about degrees, yeah, 90 would be better. But I need you to get used to radians because it's more important.
I'm used to radians, they're just
Get
stupid.
used to radians, you might as well.
How?
Okay, so with these, we're going to finish off what we started. Now, one other identity I came up with last time was cosine. I'm going to write it as x minus y, where x and y are angles, not coordinates.
What did you do?
And we came up with the formula that this was cosine of the first angle, cosine of the second angle, plus sine of the first angle, sine of the second angle. That's what we got confused about last time.
Okay, so is that the finished product?
Finished product.
That's the finished. Okay, good. Please don't explain it again.
I won't.
That right there was just like.
Well, that was a day that we had just kind of to
I'm
waste.
serious. You seriously remind me like you were in drugs when you did that.
You did it with beta and
Alpha and beta. Alpha and beta. But they're just angles anyway, so x and y, a and b, it really doesn't matter.
It does.
Does not
It
matter.
does too.
Does not matter. Alright.
Okay,
So
come on,
this
come
is
on.
called the difference of the angles cosine function, or the cosine of the difference of the angles identity. We can change this into the cosine of the sum of the angles really easy. All you have to do is take one little adjustment, change y into negative y.
So basically x plus y.
So it's basically x plus y, but we have to plug it into this identity to find out what cosine of x plus y is going to be. So this becomes cosine of the first angle, which is just x, cosine of the second angle, which is
Negative y.
negative y, plus sine of the first angle, which is x, and sine of the second angle, which is negative y. Alright. So this side becomes cosine of x plus y, and this is where the negative identities are going to kick in. Where the cosine of the negative angle becomes just plain old cosine of the regular angle. So this piece here is just going to become cosine of y. So you get cosine of x, cosine of y, and then here you have sine of a negative angle.
Which is going to be negative.
So that changes this plus to a
minus.
minus, and you get sine of x, sine of y. So these are your cosine
Why
formulas.
didn't you just write that? Like, seriously?
Why not? I want to show you how identities work.
It's just too much.
Oh, the brain is such a small thing.
Yeah.
So, easy way to remember it is cosine always goes cosine, cosine, sine, sine. And if the sine on the inside is minus here, the sine on the outside is
Plus.
plus. If the sine is plus, this one becomes
Minus.
minus. So it's cosine, cosine, sine,
So
sine,
it's opposite.
opposite of the sine.
Gotcha.
Alright, so why do we need these formulas? Well,
To do
if I want to
absolutely
find
nothing.
cosine of 15 degrees, there is no special triangle for 15 degrees. We have 30, we have 45, and we have 60. So to find the cosine of 15 degrees, what you do is, I can use either or of these, but more than likely subtract. What two angles subtract to 15 degrees?
20 and
I'm sorry.
No. Two angles that we know. We
Oh,
know 30, we know 45, and we know 60.
45 and 30.
45 and 30. So you rewrite this as cosine of 45 degrees minus 30 degrees, whose difference is 15 degrees.
So what if it's something that you can't do that with?
And then there's other methods, but we haven't gotten to those yet.
So are we going to?
Eventually, but not the main one that your calculator uses.
Wait, what?
There's a certain way your calculator figures out sine, cosine, and tangent. All right, so you have cosine of 45 minus 30. So by the formula of this one up here, is the difference of the angles. It becomes cosine of the first one, cosine of the second one. In here goes plus because this one is minus. And then it becomes sine of the first angle, sine of the second angle. Oops. Didn't mean to put that parentheses.
Could you use 60 and 45?
Yes, you could have used 60 and 45 and the same thing will pop out. Same answer will pop out, which is kind of cool. Alright, what's the cosine of 45?
1 over square root of 2.
Hold up, you gotta give us some time here.
Special triangles. Here's 45 degrees. This is 1, square root of 2, and 1.
1 over the square root of 2.
So then the other one is 30, 60, 90.
Square root of 3 over 2.
1, 2, and square root of 3.
Square root of 3
Okay,
over 2.
so it's gonna be
How'd
1
that
over the
sound?
square root of 2.
So cosine of 45 is 1 over square root of 2, also known as?
Where, do we have to do it that way?
The reason that you have to for this one is you're going to be multiplying fractions together, and it's best to have real numbers in the bottom. Real
Gotcha.
whole numbers in the bottom. I should
Cosine
say.
of 30 is the square root of 3 over 2.
Square root of 3 over 2. Plus
Plus 1 over the square root of 2. Or 2 over the square root of 2 over 2.
Square root of 2.
Who are we talking to?
square root of 2 over 2. Sine of 30?
1 over the 1 over 2.
1 over 2. Alright.
That would be the
Square root of 6.
yeah.
Well, yeah, over
Square root
4.
of 6 over 4.
Over 4. And then that one is,
The square root of 2.
so this would be square root of 2. And it's all over.
4.
So this is cosine of 15 degrees.
Can you? Why would we ever want to know that?
Yeah. For me. But personally, no. You wouldn't care.
Precisely.
Yeah, I know. So that's one possible use of this. Though, I mean, with
Possible.
calculators, you don't need it anymore.
Possible.
Possible.
Is it possible?
Possible.
So how did they come up with this equation at all anyways?
Hmm?
How did they come up with this equation in the beginning anyways?
I showed you that last week.
No, I meant
Like, how did the actual mathematician who came up with this equation, how did they come
why
up
did
with
they
it?
use sine and cosine? That's what I'm asking.
Huh?
Why did they use sine and cosine?
For or for
The cosine.
Here?
Yeah.
Why does it work out this way?
Yes.
Because of that derivation I did last week that you all hated.
Okay.
With the x3 equals x1, x2.
She's basically asking
Wait,
how
no,
the
we're gonna
How
mathematician.
do they figure it out? I
Yeah,
have
how
no
the
idea.
mathematician that created
No
this
idea.
came up with it.
No idea.
So when else are we gonna use that?
Never.
If you go
For
into
algebra?
engineering, you'll use it, and that's about it.
There and other identities where we want to create some more.
They're not even alive unless you're an engineer.
Absolutely.
Yeah,
Or a
basically,
mathematician.
or a mathematician, one of the two. All right, let's create another identity out of this. So if I have cosine of x minus y is equal to cosine of x, cosine of y, plus sine of x, sine of y.
I'm not rewriting this.
Well, I'm going to manipulate this thing to sine of x plus y. I can write this as cosine as long as I put a pi over 2
What?
minus that angle.
Why?
Wait. Say that
Because
again?
they're cofunctions.
Okay.
We talked about this. This is the acute angles of a triangle. This is one angle of the acute angle. This is the other. 90 minus whatever that first angle was. Do I have to go through that explanation again? Let me go through it again.
I get it.
You get it?
I do because it's 90.
Right.
Because some of them two are 90, and then you have to subtract x from cosine.
I guess you could think of it
What?
that way. Whatever. This angle is x plus y. We're looking for the cosine of that
Is it
angle.
just me or did anybody else hear that? Like,
Say what?
Heard you all laugh.
I definitely heard somebody do this.
That was,
Oh, Lord.
Nobody heard that? Was I
No.
she was talking about someone knocking.
the only person who heard that?
She doesn't do anything, especially on this.
Okay, what I'm going to do is, number one, distribute the negative and group the angles a little strangely. So this becomes cosine of pi over 2 minus x minus y.
Wait, hold on.
Okay.
My brain.
Distribute the negative, so it becomes negative x and negative
Why are
y.
you separating here?
There's a reason. And I'm going to attach the pi over 2 to the x, so it becomes pi over 2 minus x. And then minus y. It's just a grouping.
So you switch the parentheses.
I kind of shifted the parentheses around, but I had to distribute the negative first.
Why would you do that?
Because I know an identity that says cosine of this is equal to sine.
What I did?
Let me write it. Hold on. So you have this triangle. This is angle A. This is angle B. Alpha. This angle is beta. This side is A. This side is B. This side is C. What is the sine of alpha? A over C. What is the cosine of beta?
A
A over C. The sine of alpha is equal to the cosine of beta. But alpha plus beta is equal to
90.
pi over 2, 90 degrees, right? So therefore I can replace beta with pi over 2 minus alpha.
You did subtract over.
Pi over 2 minus alpha.
Tell me.
Okay, I just subtracted it over. Alright, and all I did was regroup them to look like this. Okay, now we can use the black formula on top. It becomes cosine of the first angle. This becomes the first angle. So it becomes cosine of pi over 2 minus x, and then cosine of the second angle, which is cosine of y. So it's cosine of the first, cosine of the second. The second angle, hold on, plus
Sine.
of
Pi over 2 minus
sine of pi over 2 minus x.
minus, well, wouldn't it be
Yeah, why isn't it negative y?
Stop that. It's
Okay.
first, second. Ignore the negative.
Okay.
It's cosine of the first, cosine of the second. Doesn't say anything about minus.
Alright. Okay.
Cosine of the first, cosine of the second, sine of the first, sine of the second. So cosine of the first, cosine of the second, plus
But if
sine
it's-
of the first,
Minus.
sine of the
Plus
second. There's no minus there, it's a
But if
product.
it's-
5 over 2 minus x.
90 minus
Beta.
Poof!
What is cosine? Cosine. 5 over 2 minus alpha
It's the
is
sine of x.
the sine of x. So this
Yay,
becomes
we're kind of smart.
sine of x, cosine of y, plus, what's the sine of pi over 2 minus x?
Cosine of x.
Cosine of x, sine of y. Ooh, it's like pulling teeth.
That's
Why?
Ah.
Right?
Back to the cofunction.
I feel like you would learn.
If you have sine of alpha is equal to a over c, and you have cosine of beta is equal to a over c, they're equal to each other, and the relationship between alpha and beta is pi over 2 minus the original angle. So if you do cosine of pi over 2 minus alpha, that becomes sine of alpha. If you have sine of pi over 2 minus alpha, that becomes cosine of, did I say that right? Cosine of
Eventually,
alpha.
I think that eventually you should. She's not gonna be sure.
Stop it. I needed to change it into cosine, but I had to use a cofunction. And then from there, it just kind of fell into place. I'll give you the next one. This one comes from those
Big
negative
price.
identities.
Big price. Please don't tell it to.
It's the
please don't
same thing except you got minus.
Yeah.
Same thing except you get a minus. And the reason for that is right here. The sine of a negative angle becomes negative. So this is
What color is your dog? You don't
I
want to
know.
get this whole fraction.
cosine of
Dude, 1 over 2 equals negative. And that's how you can burn out.
You're a troublemaker. I know you are.
Me.
All right. You need to know the two by heart. I do not give these two on the test. You need to know the sine or the cosine plus and minus, and you need to know the sine plus and minus. Memorized. I do not give them to you. You still have to know how to use them. From those two, you should be able to derive tangent of alpha plus beta. Let's get away from x and y for a little bit.
No,
I like X and Y better.
You like x and y better?
I do. It's so hard to write alpha and beta.
Yeah.
Really?
Yeah.
I guess I'm just used to it. So, tangent of x plus y.
You've been writing it longer than me.
I know. So how do you do tangent of x plus y? Well, the only things you know about are
Sine and cosine.
sine and cosine. So what's tangent in terms of sine and cosine?
A over B.
The cosine over sine or sine over cosine?
You tell me.
Sine over cosine.
Sine over cosine. So it becomes sine over
Yeah, that's it.
cosine of what?
X plus y.
X plus y.
Oh!
That doesn't change. X plus y, x plus y. Alright. What's the sine of x plus y equal to?
Hold on.
Sine
Sine of x plus y equals
Sine x
Cosine
cosine y plus cosine x sine y.
Oh my god. I was right there. Everything on the board. In the green.
It's on the board.
In the green.
For now. So the pattern for sine, I usually write it sine, cosine.
Shouldn't it be sine
Shouldn't it be
Y
sine x
and then-
cosine y?
I screwed up already. Sine.
Or yeah.
That's why I probably put cosine, because I usually go sine, cosine, and then I flip my x and y. But if you like your x and y's in order, then you have to go sine, cosine, sine. And most textbooks write it that way, but my brain is weird.
Most
Right.
textbooks write it what way? The x
They
y
write it this way.
first, the x
Yeah,
y.
they go sine x, cosine y, cosine x, sine y. But I always like going cosine, cosine.
Okay.
That's just me. All right, cosine in the bottom gets?
Cosine x cosine y minus sine
You get this ugly mess. Which tells us absolutely
Nothing.
nothing.
Can you
Now-
get slow?
We know what our goal is. Our goal is we want a formula that has tangent of the sum of the angles. Well, if I want a function of tangent of the sum of the angles, I want my other side to have, well, tangents.
Huh?
Actually, I want to divide everything by this guy.
Y.
It's just a choice. You could divide by anything up there you want, any grouping. But it's best to divide by these two.
Y.
Well, watch what happens. If I take sine x cosine y and divide by cosine x cosine y, what happens?
Sine x over cosine, which makes a tangent.
So this becomes tangent
Tangent
of
x.
x
Plus 1.
plus. Now if I take these two and divide it into this one, you get
Or sine tangent y.
tangent y. The cosine x cancels and you get sine y over cosine y, better known as tangent y.
And then
Over cosine by cosine 1 minus, and then divide this one by cosine
tangent
and sine.
xy.
It would be tangent xy.
Tangent x, tangent y.
Oh, okay. Tangent y. So
Am I
this
right?
is,
Can you explain that?
Am I right?
you're taking everything here and you're dividing by cosine of x, cosine of y. Dividing everything by cosine of x, cosine of y. So when you do the first two, you get sine of x over cosine of x, which is tangent. Then cosine of y's are going to cancel. Over here, you're going to get sine of y over cosine of y, and the cosine of x's are going to cancel. That gives you tangent y. You divide by itself, and it just becomes 1, and then these two become sine or tangent x, tangent y.
Is that as simple as it gets?
That's as simple as it gets. This one, I do not ask you to memorize.
So you're gonna give us that one.
I'll give you this one. Actually, there's a bunch of them I will give you. There's just the 4 main ones I don't. Obviously, if I do tangent of x minus y, what happens?
Just sort of, don't they just flip
This one
around?
becomes minus.
That one becomes positive.
This one becomes positive because remember, tan of a negative is going to pull out a negative out of those tan y's. So it'll switch those two signs. All right, so these are the sum and difference formulas. What else can we do with them? We're done deriving them.
I have
So,
nothing.
and we already did one possible application of them with that cosine of 15 degrees. So what about something like this?
18 degrees.
18 degrees, no, not today. Sine of 5 pi over 12. Now this is a test question. I love asking it because it takes you away from degrees and you have to think in terms of radians. And the directions will be use a sum or difference formula to figure out this thing exactly. So if we're going to find special angles that this works for, the only angles that we know that work are pi over 6, pi over 4, pi over 3, and if you want, pi over 2 can be thrown in there.
So you should change them all to 12, right? So that way you think about it that way.
Think of it in terms of 12, and it will always have a denominator of 12. So this is 2 pi over 12. This is 3 pi over 12.
Wait,
I'm changing all my angles
4
into...
pi over 12.
Which one?
4 pi
Oh,
over
darn it.
12.
4 pi over 12.
No, that
I
was
thought you were
still
doing. I
3
thought you were
pi.
higher.
Oh, you're messing me up. 3 pi over
The
12.
next one is
Next
4
one is
pi
4 pi over 12.
And then 6 pi over
And 6
12.
pi over 12. So your goal is, out of those two, you want to add up or subtract 5 pi over 12 out of 2 of these angles over here.
You could either add the 2 pi and 3 pi, or you could subtract 6 pi and 4 pi. Or wait, no, 6 pi and
And nothing.
nothing. Okay, never mind.
The only option you have is the 3 and the 2,
Add
or that's it.
That's it.
So you wouldn't do sine x equals cosine pi over 2 minus x?
Huh?
You gave us identity.
Yeah, there's an identity thing that we have to use for this. But I have to either add up to 5 pi over 12 or subtract up to it. So we're going to
Add
2 pi.
add up to it. So we're going to write this as sine of 2 pi over 12 plus 3 pi over 12. And this becomes the
Did you do
sine...
3 pi over 12 plus 2 pi over 12?
What's that?
Did you do 3 pi over 12 plus 2 pi over 12?
Doesn't matter. Addition is commutative.
Wouldn't change. Okay, so,
It'll change your first and second angle, but addition is...
but it'll be the same thing.
it'll be
Okay,
the
because
same
I didn't
answer.
know because, or wait, no, on cosine.
If
On
it's,
cosine, because it would be subtracted.
if it's minus, then yeah, that's going to be a big difference. But if it's plus, yeah, you can just switch it. It doesn't matter what function you're dealing with.
But like on cosine x plus y,
I know, it changes signs.
it changes signs when it goes
But it
over
doesn't
on the
matter.
other side. It doesn't matter, it'll still be the same
Because
thing.
addition is commutative.
Okay.
Alright, So by the formula, this becomes,
Sine of 2 pi over 12
oh, right, it is sine of pi over 6.
Okay.
Sine of pi over 6,
Cosine of pi over
4.
pi over 4,
4 plus cosine of pi over 6
pi over 6,
sine of pi over 4.
and sine of pi over 4. Then you get to have fun. Sine of pi over 6.
Cosine of pi over 6
What's
is.
sine of pi over 6?
Oh, I'm sorry, sine.
1/2.
1/2.
Yeah.
Pi over 4?
1 over square root of 2.
Right, it is square root of 2 over 2. Because we're
Right.
dealing with multiplication and addition.
Plus 3, square root of 3 over 2.
Square root of 3 over 2 for
And
cosine of
then
30.
square root of 2 over 2.
Wow. And you get square root of 2 plus the square root of 6 all over 4. Now, here's my question. That's the same answer we got earlier. For cosine of 15 degrees.
So with that, is that what cosine 15? So that's
This is cosine of 15 degrees. That was our answer from before. But this is also the sine of 5 pi over 12.
75.
because it's 90
Is it
minus.
75?
I think
Because it's pi over
75.
2 minus
It's
Right.
75.
These two angles, if you add them together, give you 6 pi over 12, which is pi over
2.
2. So these are all equal. Sine of 5 pi over 12.
So they're all 15?
Well, in this case they are.
Oh.
There's other ones you can play around with.
Is that the exact problem you're going to give us on quiz?
No.
Okay.
There's other weird ones we can do.
I have a question.
What's that?
I thought that a sine angle would be like minus 90 of cosine. That made our
90
sense.
minus it.
Yeah, that's what I meant.
And they
So
are.
why isn't it 75?
What's 15 plus 75?
Sammy.
How about this one?
Wait 5 seconds, please.
Mm-hmm. Now this is not one you type in your calculator and hit
I
equals.
wasn't planning on typing it in my calculator.
This one
So
is
thank you very
recognition.
Sine
This is a sum or difference. It's
It's
really
a
long and
difference.
ugly. And it goes sine, cosine, sine, cosine.
It's a difference
It's a difference of
of the sign.
sine. So we can rewrite this as sine of the first angle, which is 29 pi over 12, minus
11 pi over 12.
11 pi over 12, and this breaks down into the sine of,
3 pi over 2.
Hold.
slow
Oh.
down, what's
Maybe.
29 minus 11?
It's 18 pi over 12.
And 6 goes into both of them. 3 pi over 2. Sine of 3 pi
It'd be 270.
over 2. And the sine of 3 pi over 2.
No, I'm sorry. That would be the sine of 270 is what I'm saying.
It's either
Sine of 3
0 or
pi over
negative
2
1.
is 0.
Thank you.
I said 0. Or negative 1.
Oh.
No, negative 1.
Sign on the unit circle.
Unit circle.
I'm thinking.
3 pi over 2 is here. The coordinate of here is
Negative
0, negative 1, and sine is the second coordinate.
For some reason, I got that
I drew a triangle in my head and everything.
We waited for everybody to answer, and only one person got it.
Hey,
Go on
So
now.
sad.
hey,
What?
what's that?
You said 0.
I said negative 1 after the moment because I got my 0
You
from
said
my negative
0.
1.
Ah.
I said 270. So.
How about cosine of 11 pi over 12, cosine of pi over 12. Plus.
Wait, question.
Hold on.
Oh,
Let me just write this down so I don't forget it. Question.
Like,
The answer was that one, this is like -1.
Negative 1. Because after you put it together using the formula, you get 3 pi over 2. And the sine of 3 pi over 2 is -1.
Which would be like. And then the answer.
This is the cosine of
5.
x minus y, if you want to think of it that way. So it becomes cosine of the first one
Which is negative.
I know the answer.
minus the second one. Because remember, cosine goes cosine, cosine, sine, sine, and the sine is opposite.
Unity
That's plus
times
up there.
5 pi over 6.
That's cosine of 5 pi over 6.
And
We're
then
just
the
going
answer is the
backwards.
square.
Yeah, we're just going backwards.
The answer is the square.
But these I know the
Three
answer.
over
The answer is the square root of 3 over 2.
No.
What?
No.
Wait, why?
Because cosine can be obtuse.
All students take
Thank you.
calculus. Cosine in the second quadrant is negative.
Negative.
Negative square root of 3 over 2.
Minus one little sign, I was right.
One little sign is a big deal. Would you like me to write you a check for a negative $100 or 100?
I would rather have $1 billion.
Forget the 100. Give me a billion. Yeah. Signs don't matter.
They don't.
If your paycheck was negative, you'd be in a lot of hurt.
Which is why you shouldn't write
What,
negative
bosses
square
take
root of 3
money?
over 2.
Oh, yeah. All right. What else can we do with this stuff?
Do the 10.
No, I don't want to do tan. Tan's boring. Given cosine of A is equal to negative 4/5. And I know that angle A is here.
What is that? E? What is it? E?
Oh, you've never seen that?
No.
Element. Or on the interval. So the angle A's measure has to be between pi over 2 and pi. What quadrant is this in? Second. Second quadrant. So that's basically just saying angle A is in the second quadrant. Element means element.
Right.
Tangent of beta, B,
Thank you.
is equal to 21/20. Right. And angle B is on the interval from pi to 3 pi over 2.
Third.
So this is Q3. This one is Q2.
Why do you write it in Roman numerals? It's so much easier to write
I
than
don't know. When you write quadrants, it's Roman numerals. Who decided that? I don't know.
stupid who had no life.
What I want to find is sine of A minus B.
It does not.
It's impossible.
Yes, no, it's not impossible, otherwise it wouldn't ask. So what can I
Yes,
do?
you would.
No, I wouldn't.
No.
What can I do with this information over here? That cosine of A is equal to negative 4/5, and I know it's in the quadrant 2.
Change the meridian.
No. How about draw a
Picture.
picture?
That too.
So you draw a picture.
Drawing time.
You call it the A picture because it's angle A. We know it's going to be in quadrant 2, so you draw a triangle in quadrant 2. Remember doing this, right?
Yeah.
How would I label the sides?
Yeah, it was like 2
But
weeks
why is
ago.
there
I know.
I watched
It
one.
was last week. What are you talking about?
No, it wasn't.
Why is there sine A minus B?
Because I'm asking this. I want to find sine of A minus
Okay.
B.
We're going
Which
to make
angle?
specific
Oh,
thing 2 weeks ago.
It was last week we had the test on this.
-4 will be on the bottom.
Negative 4 would be on the bottom.
Back side.
That's not what we learned.
5 up here.
And 3 on the other side.
And
Yeah.
positive 3 on the other side because it's going.
That's
Up.
And it's a 3, 4, 5.
B picture.
20 on the top.
What quadrant?
Third.
Third. So you'd be down here drawing your triangle. Its tangent is 21/20, so
Why
opposite becomes
21.
21, but it's negative because it's going.
And it would be 20,
And it'd be 20 on this side, and it's
Negative.
negative.
29.
And 29. I wrote the triplets over here. In case
Wait,
you
what are
want.
those?
These are the
So
Pythagorean
this-
triples.
Yeah.
20
Like a
squared plus
3, 4,
21
5.
squared equals 29 squared. So this side is.
My daddy talks about this stuff.
29.
Okay.
Alright, so the formula for sine of A minus B is sine of the first one, A, I'll give you that much.
Then it's
Cosine
B.
Cosine of the second one.
minus cosine A
Sine
from B.
We'll go with the book. All right, and then you just have to evaluate each one of these pieces. What's the sine of A?
The sine of A
Remember, this is picture
is
A.
negative
Three-
or 3/5.
It's 3/5. So this gets a 3/5. Cosine of B,
Negative 20/29.
negative 20/29. Minus cosine of A,
Negative 21/29.
cosine of A,
Oh, I'm sorry.
It was given
Negative
to us.
4/5.
negative 4/5. Or off the picture, negative 4/5. Sine of B,
Negative 21/29.
negative 21/29.
So technically, I was kind of right.
And now you can use your calculator to do the rest of it. Because this is a pain.
Yay!
5 times 20, I don't want to do this. This would be negative
Wait,
60,
no. But you can take, you can do 3
minus-
over 1.
84,
You're doing this all wrong.
negative 144 over something. 145? 144 over 145?
Hold
I
on.
don't have a calculator.
Yeah, but I don't want to use it.
If I made you do this by hand, trust me, you'd want to
Wait.
use it.
It's telling me that oh wait,
It's telling me I made an error.
negative
145.
0.993.
No decimals. Hit math, enter, please.
Negative 144 over 145.
Which is, wait, did you just say negative 144 over negative 145?
No, over 145.
Negative 144 over
145.
145.
I'm not stupid. I'm not.
No comment.
Give me some credit here. I have my moments, but don't y'all.
So that's the answer.
That's the answer. Your turn.
Hey.
Given.
Oh, great.
Sine of A is equal to negative 3/7. This is not a special triangle, by the way. And A is Q4. Tangent of B is equal to 2/5. And B is quadrant 2. No, 3.
It can't be.
3.
Good. See, at least I've been listening.
Find tangent of A minus B. Oh, great. Oh, by the way, perfect quiz questions. I can't do much for the first section for quizzes because they take way too long. And I don't want to waste the time with it, but these are really quick and easy.
So we're not
And they
having
tell me
quizzes
if you
lately?
understand what an identity
So we're not
is.
gonna have any quizzes?
Tomorrow.
Oh.
That's what I'm saying. You're not going to get one on the first section because it's too hard to write a quiz for. But this stuff, what is it? It's tan A
Minus tan B
minus tan B
over 1 plus tan A tan B.
tan A tan B. Alright, so tan A gets,
Negative 3 divided by square root of 40
oh fine, we'll leave it like that. Negative 3 divided by the square root of 40
minus
minus
2 divided by 5 since it was negative.
2/5. Well, that was given too. Tan
Yeah.
Over 1 plus negative 3 over the square root of 40 times
Whatever.
2/5.
And we get decimals.
Well,
Wait, why did you get the square root of 40?
49 minus 9.
Yeah, so it would be 2 on the square root of 10.
Well, same thing as the square root of 40.
So I thought you wanted to just like.
Give me 2 seconds and then I'll get it back to 2 square roots of 10.
Because I said going on.
How do you get rid of that ugly mess? What can you multiply by? The common denominator is square root of 40 and 5. So 5 square roots of 40. So you multiply top and bottom by 5 square roots of 40. Try to simplify it. Let's see. This times this.
That would be 15, negative 15.
negative 15. This times
oh
this.
my god. That did not happen for me.
2 times square root of 40. This times that, of course, is
5 square root of 40.
ugh, it's still ugly. And that's going to be a negative
Let's just do plus and then we'll
minus 6.
Huh?
Well, this is 5 square roots of 40 times this product, and the bottom has a 5 square roots of 40 in it, so the 5 square roots of 40s are going to cancel, and you're left with minus 6. Uh-huh.
No.
Yes. Yes. Why no? Ah. What's negative 2 square roots of
So
40
does
times?
that equal the negative square root
Well,
of
that's
negative
6. 5
3 on the
square
square root
roots
of 10 minus 8 over 20. All over.
Yeah, then it gets ugly.
I
So-
did like
But if
some
you
fractions
did it the other
inside
way.
of fractions stuff.
Negative 15 minus 4 square roots of 10
10.
over 10 square roots of 10 minus 6. You can rationalize that if you want, but
No, I'm good.
it's almost not worth it. So that would be the tan of A minus B.